Hello friends. Now this is the mechanical application of electrostatics 10th video. Here we should deal with again another type of a sum. Principle is energy conservation. Okay. Now you consider this is an object having charge Q2. Suppose Q2 is fixed and here an object of mass m having charge q1 is entering into the electric field with speed u. Direction of the electric field is from left to right. Okay, initial speed of q1 is large. Now if this is the case, then q1 experiences a retarding force, that is eq. Due to that retarding force, its speed goes on decreasing. Okay, and the object is brought to rest somewhere here. Suppose it is brought to rest somewhere here. Now initial distance of q1 and q2, you take r1. Final distance is you take r2. So in this case, to find out the kinematic properties or dynamic properties, you can use the energy conservation. That means loss of kinetic energy half m u square minus v square. Here v is 0, final velocity is 0. Loss of kinetic energy that equal to gain in electrostatic potential energy. That means small k q1 q2 divided by final distance is r2 and initial distance is r1. So this is your value. Now what is k? That is k is 1 by 4 pi epsilon naught if you take this is in air or vacuum. Okay. Now if you take this type of a formula, then the loss of kinetic energy is equal to your gain in potential energy if q1, q2, r1, r2 all are given. Then you can find out what is the speed required, that is u. Okay, what is the speed required, that is u, or what is q1. If speed is given, you can find out what is q1. Okay, if you find out q1, then what is force? Force is eq1. This is eq1, retarding force. Okay, now this is the case. Now again from this formula you can find out when the object displaces from this point to this point. Should say A to B. I am giving what is AB. AB is R1 minus R2. Let us take this as a S. Okay, this as a S. Now what is the acceleration? Acceleration is v square minus u square divided by 2a, that is eq by m. This is the value minus, because it is a retardation. So in this way you can find out, or eq by n, 2a, sorry, this is 2a into what writes s, v square minus u square by 2s, or s equal to v square minus u square divided by 2 into a, means this is eq1 divided by m. So you can find out what is the distance traveled by the charge in the presence of opposing electric field. Now similarly, instead of q1, if you take q1 is negative. In case of a negative, velocity goes on increasing. That means v is final velocity is greater than u. If v is greater than u, then you can find out what is the distance traveled after traveling some distance, certain distance or a particular time. Okay, or to get particular velocity, what should be the initial velocity. So you can find out the kinematics equation by using the either electric field is reversing or nature of charge is changing. That is, instead of plus q, you can take minus q. Now, if you imagine again the previous case, system is as it is, field is towards right, q1 is starting from u, it is brought v, brought to rest at b point where velocity is 0. But the medium is a viscous medium. If the medium is a viscous medium, then that is here work done against the friction comes. That means resultant force is not EQ1. Okay, resultant force is, that is the mass experiences force 1 due to electric field and another due to viscous force 6 pi eta RV. And V is a variable term. It varies from point to point. Okay, so you can calculate by taking viscous medium in the presence of within the electric field. Similarly, you come to the second figure. Suppose instead of a charge is moving, I am taking a block. This block has the same thing, mass m1, charge q1. This is mass m2 and charge q2. Okay. Now, this is if the charge q1 mark, this q1 is moving with velocity u like this. You can use the same formula. This is fixed, same thing. This is fixed. Then you write half m into u square minus 0 square. This is k q1 q2 divided by final distance minus initial distance. Same formula. But if you take, if the object is moving, then there is a friction in the ground. That is friction. This is mu n1g. There is a friction in the ground. Then in this case, that is work done is gain in potential energy plus work done by the friction is mu n1g. You can put it m1g into s if the body brought to rest after traveling this much distance, s distance, mu m1g s. Now, how can you calculate the value of s? The formula is given. Instead of a force EQ by m, you take this force FH, that is EQ1 plus mu n1g s, mu n1g. So therefore acceleration is EQ1 plus mu n1g. This is mu g divided by n1. So this is your acceleration. If you put the value of acceleration here, you can find out the displacement traveled against the electrostatic force and what is the time taken to cover that much distance. Okay. Now let us come to the same situation. Now here you take second body, M2 is fixed, but here M2 is not fixed, but it is at rest. Now M2 possesses charge Q2, M1 possesses charge Q1. M1 enters into the electric field with U. The electric field opposes the motion. Okay? Opposes the motion. Now the surface is a smooth, same situation, but this is fixed and this is rest. Okay? This is smooth. You take first smooth, then rough, but this is totally smooth. Now, when the body is moving against the system, its distance goes on decreasing. Distance goes on decreasing means electrostatic repulsion goes on increasing. Okay? Electrostatic repulsion goes on increasing means if the two bodies are at a certain minimum distance should say R, both move. Okay, both move with same speed, in same direction. If Q1 equal to Q2, M1 equal to M2, and in this type of a case. This is not rest. Not rest means if the body is repelling, means this is moving, both are moving, okay? But there is a minimum distance. Its velocity start from 0. Its velocity is initially u, okay? Rapidly its distance goes on decreasing. When it comes to a minimum distance, at that minimum distance r, both the two bodies, they appears to move. They move along same direction, okay? In the presence of electric field. So Q1 equal to Q2, M1 equal to M2. Now at that instant, how can you write down the equation of motion? Same instant. That means after that what happens, we do not bother about that, what is going on. Now at that instant, if you want to calculate the kinematic properties, that means at the minimum distance r, this is the condition. First you use conservation of momentum, because it is a type of a collision, okay? Conservation of momentum, that is m u1 or u that is equal to, that is m1 v mv plus mv, that is equal to, from this v becomes u by 2, okay? V equal to u by 2. Then you can use energy conservation. Energy conservation. This is half m u square, that is equal to half m v square plus half m v square plus at minimum separation electrostatic potential energy is q square divided by r. What is q? Both magnitudes same. Q1 equal to Q2 equal to, you write Q here. Q1 equal to Q2 equal to, you write Q. So this is your equation. Now how many symbols are there? That is, if all are given except any one symbol, you can calculate that properties with the help of this type of a equation. Okay? Now finally, let us see this example. This is a sphere of mass m2 and positive charge q2. It is a conductor, but total charge appears to be concentrated at its center. That is called center of charge. Okay? It is the center of charge. Q2 appears to be concentrated. Now this is radius. I am taking big R. Now from the surface of sphere, here there is a particle whose mass is m1, charge is q1, and weight of the charge, there is no electric field. Weight of the charge is m1g. If the object is dropped some height, due to the weight, it is moving down and down. That means distance between two charges goes on decreasing. Now, since force is inversely proportional to r square, if distance increases means repelling force increases. That means the charge experiences upward force. Now the Q1 and M1 are given, arranged in such a manner that suppose the object is able to reach the surface, able to reach just the surface. If it is able to reach, its mass is something, charge is something, so that it is able to just reach the outer surface, should say, just that is outer surface. So in this case, what should be the value of M1 or what should be the value of Q2? So now here again, effect of gravity and effect of electric field both are taken into account, and you can take here the electrostatic energy and gravitational energy varies. Okay? When the charge is here, it is at the distance you take, that is some smaller from the center of the charge. When the charge is on the surface, its distance is, should say, that is r minus r. Okay? This is the value. Or if you take, this is smaller from the surface, should say, it is better. This is a bigger. Okay? This is bigger. Then in that case, when the charge is here, potential energy is U1. When the charge is on the surface, potential energy is U2. So what is gain in electrostatic potential energy? So gain in electrostatic potential energy is U2 minus U1. Charges are same. Take Q1, Q2. You take out common. That is U2 first means 1 by R plus R minus 1 by R. This is the final. Because finally body is here. This is the distance. Initially, this is the distance. Okay, sorry, 1 by not smaller. Final distance is this is. Body comes this much distance. That means finally it is bigger. Initially it is at a distance what? R plus R. Okay, to take two symbols, mark R plus R. If you take this is total symbol is R naught, then you can write out this is take Q1 Q2 divided by 1 by R naught minus 1 by R. If you want to write like this, that means why I am writing like this? Because total distance is radius of the sphere plus height of the sphere from the surface, height of the charge from the surface of the sphere. Okay. Now, if this is the case, then this potential energy or this potential energy is gained by the charge during the motion, and that equal to which charge is in motion? M1. What is its mass? That is M1. Body is freely falling. Acceleration due to gravity is G. That is M1G. Okay. M1G into initial distance. This total distance is R naught minus, that is final height is R. That means you take this as a base. This is the total height H minus H prime. H is this is R naught. H prime is this is R. So M1G into R naught minus R. If you put this equation into account, if you take this equation into account, this is okay. That is M1G, instead of R naught you put R plus R minus R. Okay, R plus R minus R, that means M1G into R. If you take this, then find out which physical quantities are known. Okay, and a problem for you, that is, let us solve. You try to solve this equation. First you take Q1 equal to Q, where is Q2 equal to 2Q. You take a problem for you. Let us solve it. Okay, Q1 equal to Q, Q2 equal to 2Q. Should say R equal to 9 meter, capital R equal to 1 meter. R are given. Okay, then comes to masses M1 and M2. Okay, now M1 equal to, you put M, then M2, or no, only one M1, you put M1 equal to 100 gram. Suppose there is no M2, then find out what is Q. Okay, that means all symbols are known. Here Q1 equal to Q, Q2 equal to 2Q. So you can find out the value of Q, a problem for you. Okay. Now, dear students, if you like it, like and subscribe. Okay, thank you.